In just 3 minutes, we will discuss multi-domain modeling and simulation using MATLAB and Simulink, using the example of a robot dog running on a platform. Now, upon hearing this, you may ask questions such as, what is multi-domain modeling? Why would I want to do that? What benefits are there to multi-domain modeling? Well, multi-domain modeling and simulation involves creating models involving various engineering domains such as electrical, mechanical, fluid, and thermal, all within a single simulation environment. This allows for complex systems involving various engineering domains to accurately interact with each other and exchange information. With MATLAB and Simulink, you can design systems with multi-domain models, simulate before moving to hardware, and deploy without writing code. Let's take the example of a robot dog shown over here. Here the robot dog is running freely on a platform with accurate biomechanics representing its running gait. How did we achieve this? With the help of Simulink, Simscape, and Stateflow, we were able to simulate the running dynamics of the robot using parameterized blocks. The software interface you're seeing currently is called Simulink. Simulink is a block diagram environment used to design systems with multi-domain models and simulate them to observe their behavior. Let's start this whole process by looking at the Stateflow chart, which is this yellow block over here. Stateflow allows us to represent specific states of the simulation, such as when the robot is in the air, which is represented by this transition state over here, as well as when its feet touches the ground, which is represented by this one over here. It allows us to send specific instructions to the robot's leg subsystems, shown over here, during the aforementioned states. That allows us to activate Simulink and Simscape blocks in the knee and hip actuators situated over here. That output a torque to the knee and hips, allowing the robot to move its upper and lower legs, resembling a jogging dog. You may also wonder, how did we build the robot's legs? Well, Simscape Multibody allows us to construct rudimentary shapes of the different robot parts, such as the leg, which is shown over here, as well as the knee and joints, and connect them together using rigid transform blocks, as shown over here. These blocks each consist of a base and follower port, where the body connected to the follower port can be attached to the body connected to the base port, and even rotated or translated by a certain distance, if preferred by the user. Moving to the hip actuator subsystem, we used a Revolute joint shown over here from Simscape Multibody that accepts a torque input from a servo motor, which is represented as an electromechanical block shown over here. The servo motor output shaft is connected to a gearbox block, which either generates a higher or lower torque output from the servo motor. That torque output, as mentioned, is connected to the Revolute joint and provides the correct torque value at the correct time, where the correct time is decided by the Stateflow chart mentioned earlier. This allows us to replicate the running gait. For more information, please contact Opti-Num Solutions and be sure to give us a follow on LinkedIn for more content.